Alright, so let's move on to question number 4. So a person kicks a ball with initial velocity directed 53 degrees above the horizontal. The ball lands on a roof 7.2 meters high. The wall of the building is 25 meters away, and it takes the ball 2.1 seconds to pass directly over the wall. Calculate the initial velocity of the ball, determine the horizontal range of the ball, and by what vertical distance does the ball clear the wall of the building. So I'm going to draw a diagram. I've already gone ahead and done this, so it's easier for you guys to understand. So let's say this is where you kick the ball, and the angle is 53 degrees at some velocity, but you don't know the velocity. You're given the angle, you know how far the wall is from you, which is 25 meters, and you know how high the wall is when the ball falls on it, which is 7.2 meters. It takes 2.1 seconds for the ball to pass the wall. So the wall is 25 meters away from you. So basically it takes 2.1 seconds to pass this wall, for the ball to pass, which means it takes 2.1 seconds for this entire distance, because the wall is 25 meters away from you, and since it takes 2.1 seconds to pass the wall, that means it would take 2.1 seconds for this entire distance of 25 meters. So we can go ahead and do this. So VIX equals 25 meters over 2.1 seconds, 2.25 meters to the right, and 2.1 seconds, and that gives us 11.904 meters per second to the right. Now we want to calculate the velocity. We know that VIX is the adjacent side and VI is the hypotenuse. We are given the angle, so we can just use cosine 53 equals VIX over VI, because it's adjacent over hypotenuse, because it's cosine. So cos 53 equals VIX over VI. VI equals VIX over cos. So we get 11.904 over cos 53. And that gives us 19.78 meters, which is approximately 2.0 times 10 to the power 1 meters per second, 53 degrees above the horizontal. This is meters per second, by the way, because it's velocity. So I just basically rounded this to 20 meters per second. So yeah, that's how you find part A. Now part B, determine the horizontal range of the ball. So to do this part, we would have to find out how long it takes for the ball to hit the top of the roof, or how long it takes for the ball to land on the top of the roof. So then once we find that time, we can just multiply that time by the velocity in the x direction, and that would give us the displacement in the x direction. So first we have to find out how long it takes for the ball to hit the top of the roof. So time we have to find. We have acceleration in the y direction, which is negative 9.8. Up. We can find our y component velocity by doing, since we have the actual velocity, we can just do 19.78 meters per second times sine 53, because you remember from before, sine 53 equals opposite over hypotenuse. Since we want this, we just use sine 53, and since we have this, we can just do sine 53 times this. VI is basically this times sine 53. That gives us 15.798 meters per second up. Now we can find time. We know the displacement when going on the top is 25 meters, or 7.2 meters, sorry, 7.2 meters, because 7.2 meters up. So we can just use the formula displacement equals VIY times time plus half acceleration times time squared. 7.2 times 15.798 times time plus half negative 9.8 times squared. 0 equals negative 4.9 times time squared plus 15.798 times time minus 7.2. So now this ends up being a quadratic equation. We want to find time, so we can just do x equals, we can just use the quadratic formula, minus b plus minus root b squared minus 4ac divided by 2a. This would be a value, this would be your b value, and this would be c value. Plug it into this equation, and you should end up getting time as 2.6747 seconds. So now that we have this, we can find out the range of the ball. So we already have the velocity in the x direction times time. We have the velocity in the x direction, which we found before, which was 11.904 meters per second to the right. 0.904 second right times 2.6747 seconds. Seconds and seconds cancel. So 11.904 times 2.6747, and we end up getting 31.84 meters to the right, which is approximately 32 meters to the right. So that's how you do part B. Now part C, the question is asking by what vertical distance does the ball clear the wall of the building. So to do this part, I'm just going to redraw the diagram again. So this was velocity initial. This was 53 degrees. This was where the building was, and it lands right up here. The distance from here to the building was 25 meters, and the height of the building was 7.2 meters. And we know that once the ball passed the building, so once it came from here to here and it passed above the building, it took 2.1 seconds. So time was 2.1 seconds. So basically, since we have the y component of the velocity that we calculated right up here, we can just find out the displacement. So at 2.1 seconds, how high was the ball? By getting that displacement or the height, we can compare that with this height, and we can determine how much higher that the ball was at this point when it was clearing right above the building. So I'm just going to do this. Displacement equals VIY times time plus half acceleration times time squared. VIY is 15.798 times 2.1 plus half negative 9.8 times 2.1 squared, and I end up getting 11.5668 meters up. So in 2.1 seconds, the ball is 11.5668 meters. Just as it's in 2.1 seconds, that's how high it is. And since in 2.1 seconds it clears the top of the building, and since the top of the building is 7.2 meters, that means at 2.1 seconds, just as the ball clears the building, it clears the building by 11.56 meters minus 7.2 meters, which is approximately 4.4 meters. So that's approximately how much the ball clears the building once it's at 2.1 seconds. So yeah, that's basically how you do question number 4. And question number 5 is almost the same as the previous questions. I might do question number 6 and maybe 7, but I don't know if I'll have that much time in this video, so I might leave question number 6 for the next video because it's a little bit more lengthy, and maybe I'll do question number 7 or 8, but like, you guys can have a try at these, and yeah, I'll see you guys in the next video.